Hey brothers and sisters, Dominic Lucero here. I'm the instructor for Boilermakers Local Lodge 549 in Pittsburgh, California. Moving along in our video series on measurements. The last video we did was decimals to fractions to kind of lead us up to this point right here where we can no longer read measurements in a fractional sense where we actually have to read them in decimals. So today we're going to be talking about calipers and specifically vernier calipers. This is very important because, in my opinion, the apprenticeship is not necessarily to train people how to be hands. Although we all need to be hands, I believe the apprenticeship program is here to train people to be able to fill any slot at any time on any job site, particularly supervision. So if you're supervision and you have to do some ordering of material, or even if you're doing some layout and some fabrication and you need to know the thicknesses, diameter, so on and so forth, most of the time we're going to be using calipers. Tape measures can't cut it. For example, if you've ever heard the term 105 wall tube, it's 105 thousandths of an inch. So 125 thousandths would be 1/8. So the tube is going to be, the tube wall thickness is smaller than 1/8. So we can't rely on fractional dimensions all the time. We have to be able to read decimal dimensions as well. So I'm going to try to get this close to you guys. This is a 12-inch vernier caliper. And the way it works is it has a thumb screw on here that rolls this back. And as you can see, as I roll it back, that dial is spinning. Inside here on the neck of it, we have little marks. You can see right here we have 0, and it moves to 1, and that is 1 inch. And then if you look even closer, inside that, we have 9 little marks or 10 divisions on the inside, and that is in tenths of an inch. And then over here, it goes from 0 all the way up to 100 right here, and that's going to be for our hundredths and our thousandths. So I'll explain that a little bit more. I have a blown up version right here to try to make it a little bit easier. And as you can see, I have 500 thousandths, which from our last video we went over, that is 1/2 inch, or 50 cents of a dollar, 1/2. So as you can see, on the chart from 0 inch to 1 inch, we have our divisions on it. So if we slid this back, if we slid the body back, right where this meets up with those numbers right there is where we're going to pull this measurement. So if we slid that back to 500, that would be our tenths place. And then we would come over to this dial. And for 500 thousandths, it would be reading 0, which would be interpreted as 0, 0. So 0 for hundredths and 0 for thousandths. So let's try another measurement. If we were trying to pull 5/8, and hopefully you've been practicing your fractions to decimals, we know that 5/8 of an inch, the way we're going to find out what the decimal form is we're going to divide 5 by 8. So 8 is our whole, and we want to know how many how many of those eighths will go into that 5, and that will give us our percentage of 0.625. So that is the decimal form of 5/8 of an inch. So how we would find that is we would slide back our vernier calipers until we get to the 6 mark. And something that's really important, you have to be able to fully see this line on the 6 mark. And that 6 represents our 6/10ths of an inch. And what that would look like would be that, 6/10ths of an inch. Now we still have the hundredths and the thousandths. So we would come over here and our dial would be pointing somewhere right about there. And that would be at 20. So 20 would be our hundredths. And then we would have 5, which would be our thousandths. And that's what it would look like to be able to pull 5/8 on a vernier caliper. And I have some real hands-on examples I'm going to show you here in a second. So I'll go ahead and move the camera and we'll take a look at that. So what I have here is just a little something I 3D printed for you guys just to be able to give us a range of different measurements just for a little bit of practice or practical application and how to use these calipers. So let's go ahead and pull some measurements. I'm going to let you know right off the bat, when I was testing it out this morning, I seen that my 3D printer is about 10 thousandths of an inch off. So we're going to have to do a little bit of rounding, which is completely fine. A lot of times the stuff that we're working with in the field is not extremely precision and precise dimensions. So it's important to know which measurement is closest to which is why I really want to stress the importance of knowing your fractions to decimals. So we'll go ahead and pull one really quick dimension off of here. We'll just pull the overall dimension off this square. And the first thing you want to do always when working with veneer calipers or any calipers is you want to open it up and you want to make sure the inside of here is nice and clean. And then you want to close it and make sure that we are actually reading 0, and we are. If you're not, this little thumb screw up here, or down here rather, you can loosen it up and you can actually turn this around to make sure you're actually hitting 0 to set it and calibrate it. I'll go ahead and lock that right back into place. The second thumb screw up here is whenever you go to pull a measurement, you get that measurement, you get it real nice in there, you can lock this in and it won't move anymore, and it'll lock that dimension in so you can read it. So make sure that we open this up big enough. I'm going to hold it right here in the jaws. Get this close. Just, you never really want to, you don't want to wrench down on these. You just want to get it where it sits nice and tight, nice and square. I'll go ahead and pull this off and we'll take a look. So, it's a really good example. We can see we're right here at the 4-inch mark, but right over here we see it's 90, and we don't see the next division coming after 4. So that means that this is not exactly 4 inches, and that's really important. You have to be able to see that line right there. Even though we could see the whole number 4, we are just shy, because if you look, now we're at 0, now we're exactly at 4 inches, and you can see the line on that 4. So really what our measurement is actually, and it's very helpful to write this down, 3.990, like that. So, and how I know that is, since we're not all the way at the 4, we are in the 3-inch range. And because we have not passed that division line right there, we are still in the 9/10 range. And then, of course, over here on our dial, it's at 90, so that's 90 hundredths, and then it's at the 0 mark for 9 thousandths, or for 90 thousandths of an inch. So that's what that would look like. Let's pull another dimension. I'll pull this one right here, the top square. Okay, lock it in. So if we look, we are at the 2-inch mark. There we go, 2-inch mark. I'll write that number down first. 2 point, because it's not exactly 2-inch. And if we look, we are at the 4/10 mark. We're just over the 4/10 mark. So 2.4. So that's our tenths. Now we're going to move over to our hundredths. We see that this number right here, we are in the 30 range. So the 30 hundredths. So 2.43. And then for the thousandths, if we look, we're about 5. So 2.435. And my guess is that measurement was supposed to be 2.437, which would be 7/16 of an inch, which is why it's so important to be able to use your decimal conversions, your fraction conversions. So also, as far as math is concerned, using this form of measurement is a lot faster. So if I actually wanted to see how much this was off of 2 7/16, because 2.435 does not have a fraction assigned to it. And if it does, it's going to be an insane fraction. So 2.4375 is what 7/16 would actually be. And now I can subtract that from the measurement I actually got. And what we have is 25 10,000ths of an inch, or 2.5 thousandths of an inch shy of 2 7/16. It does take a little bit of practice. Don't feel like this is going to go over your head. I promise you it's not. Once you get familiar with the language of it, it makes a lot more sense. So that's kind of the basics of how to use a vernier caliper. Now I can tell you a lot of times when people are getting calipers, whether they're ordering them or they find them, a lot of times we're going to have digital calipers. And these are my personal calipers. It's Mitutoyo. They're high-end, super accurate, really smooth kind of motion. So I'll go ahead and turn these on, and let's see some other features of calipers that make them very useful on the job. If you notice, as I extend this, the back end comes out, and that should be true for every caliper on there. This is coming out in proportion with how much this opens. So it's the exact same measurement. So if I wanted to check what the distance is from this first square here down to the second square, I can simply set it on there, come down on it, and you can see it is 0.185, which I'm guessing is supposed to be 3/16, which is 0.1875. If I wanted to see the distance from the top to the bottom one, once again, I can just set it on edge, and I can slide it down, and that gives me 0.4235, which is pretty close to 7/16 of an inch off. So another cool feature is the back side is meant for pulling inside diameters. So if I have, excuse me, if I have a feature that goes down into something, I can pull the diameter just like that. And we can see that the inside diameter on this one is 0.436, or very close to 3/4 of an inch, 0.75. I can pull the outside diameter on a boss or on a raised feature, and we can see that is roughly 0.8755, or 7/8 of an inch, 0.875, and something else that's very useful. If I needed to find center to center distance, all I have to know is the diameter, so 0.875, and now I'll pull the overall distance between the two. There we go. The overall distance on the outside diameter is 2.364. I'm guessing that's supposed to be 2.375, which would be 2 3/8. So in order to find the center to center distance on here, I want to take off the radius, which is half the diameter for both of these circles. Now, 2 radii is going to equal 1 full diameter. So if I subtract 1 full diameter from the overall length on this, it's going to give me the center to center distance between the two. And you can see how quick that math really is. Subtracting 7/8 from 2 3/8 gives me 1.5 inch. Now, if I want to find the center distance to the center feature that's in between them, that little hole, all I have to do is divide that by 2. And being able to move between decimals and fractions makes life a lot easier, because I can divide 1.5 into 2 if I like, or I can just turn it right back into fractions, where I know that 1.5 inch, I know half of 1 inch is 1/2 inch, and I know half of a 1/2 inch is 1/4. So that's the two numbers that I end up getting out of splitting this number in half, which would give me 1/4 inch plus 1/2 inch, gives me 3/4 of an inch from center of the raised face to the center of the feature that goes in. And very quickly, we'll just check that. I'll set this to 3/4 of an inch, 0.75. I'll lock it in place, and let's see if we can compare that measurement to what it actually looks like. I'll put it as close to the center as possible, and there we go. And you can see that that measurement is exactly accurate, and we didn't have to eyeball anything, which is really important. Eyeballing is just a really bad practice. So one more cool feature, in here we have a deep hole, and we can very easily use this backside right here to get the depth. And I have 1.131, which 1 1/8 would be 1.125, which is, once again, just the ease of being able to move to measurements going between fractions and decimals. So something a little bit more real world than a 3D printed object. Hopefully something that we've all seen before. I have here 3 tubes. This is your standard monster coupon, something that you'll see for your common arc test. And we've always been told that it is 5/8 wall. So let's double check. If you look there, I have 0.6695. So just a little bit over, about 30 thousandths over 5/8 wall. Let's see what that would look like on the veneer caliper. I'll lock this in place. And if we look, we have 0.6. We see the 7, but it's not all the way past the 7. So we have 0.6, and then we have 7.5. So what that would look like, so about 10 thousandths of an inch difference between our two readings. That would look like 675 thousandths. Now if we pull our dimension on this one, I'll turn it upside down to get the flat end without a burr on it. We can see that that is 0.4615, which is really close to 0.4375. So this is 7/16 wall. But a lot of times things don't add up to nice fractional numbers. For example, a standard tube that we might be welding out there. So I'll check outside diameter. I'll set it on here and I'll just kind of swing it until it just barely glances by. You can see we have 2 505 thousandths, or 2.5 inches. We can pull inside diameter. I'll just move it until it's at its maximum, very lightly expanding it, not wrenching down on it. And we'll see we have 1.907, or 1 907 thousandths of an inch. Right there, that would be able to tell us our wall thickness. If we subtracted that from the outside diameter and divided it by 2, that would give us this measurement right here, but we'll pull it real quick. And we'll see right there we have 303 thousandths of an inch. So that is not a fractional number. If anything, that's pretty close to 5/16, which is 0.3125. But a lot of times things aren't measured in standard fractional units. For example, the 105 wall tube. And if you pull your tape on there and you order a 1/8 wall tube, you might be putting the wrong material in it, which is why it's so important to know this stuff. So this is just a very brief introduction into calipers and their use. These are extremely versatile tools, and I plan on making a whole video just dedicated to using calipers in layout. I've caught a lot of guff over the years for my use of calipers. People think I'm trying to be too precise, but honestly, it's way faster than the tape measure. Extremely fast, it's efficient, and it's accurate. So I hope this was helpful. If you have any questions, stop by the training center anytime. I'm happy to sit down with you, and I hope you get the education you deserve.